Greetings everyone, this is Jeff Wilkerson, Professor of Physics at Luther College, bringing you the next in our series of what to look for in the night sky. This time we're talking about the week of December 19th, 2022, about to wrap up the year. So, it's been, I hope wherever you are, you've had a chance to see some night sky. It's been pretty dreary here. The entire week of Geminid meteor shower was washed out for us, and we haven't seen the night sky in quite a while. But the thing is, that never lasts, so we've got a chance to look forward and see what we might see in the week ahead and then in the weeks after that. So let's jump right in. As we think about this week coming up, on the morning of the 20th, the moon will be about 10% full, so a beautiful sliver of a crescent moon to be checking out. And it's sitting in Libra, and we've seen it, so you go out before sunrise when it's this thin of a crescent and waning. You've got to get out just before sunrise to see it, maybe an hour or two there. And it's sitting in Libra, and we've looked at this before. So in recent weeks, the moon has had some occultation opportunities. Zubayn al-Ganubi, Zubayn al-Ganubi, this star right here in Libra, is a star that it has a chance to pass across once in a while. So there's this triangle of sort of third to fourth magnitude star, 2.5 magnitude to fourth magnitude star. Pretty bright stars, actually. So they shouldn't have a lot of trouble seeing them. The moon sits right below this triangle, about 10% full on the morning of the 20th. So a good chance to see a beautiful crescent moon. By the morning of the 21st, it's faded away to about 6% full. And at 6% full, it's a challenge to see. It's not up much before the sun is, and so you don't have much chance to see it before the sun comes up and washes it out. You should be able to see it, and particularly with optical aid. A pair of binoculars ought to help you pull this thing out here. And at 6% full, this is an observable moon. But it's not going to be observable if it's much less full and gets much closer to the sun. Interestingly enough, remember that a fist held out at arm's length is about 10 degrees, and the moon is sitting about 23 degrees, between 20 and 25 degrees from the sun at this point. So that's how far away it is from the sun in the sky. How much, you get a sense of how much higher it can get in the sky before the sun appears. It can get about 23 degrees above the horizon before the sun pops over the horizon. But of course it starts to get daylight before the sun pops over the horizon, and so you have a little bit of a challenge there. It's starting to get washed out, and so you get a sense of the morning glow. You're going to be wanting to try to dig this 6% crescent moon out. No problem there, I think you can do it, and it's worth trying to do. Interesting to think about, and we'll swing back to this in a moment, but it's interesting for me to think about where the moon is right now against the background stars. So let's just go ahead and draw. Let's just go ahead and draw what we're about to talk about here. Here's the sun, and here's the Earth in orbit around the sun. Now, when we see the sun here, we can see things near the sun over here and over here, and so we see the stars that are back over here. The sun is sitting squarely in the constellation Sagittarius right now. The open star cluster M23 that I like to take pictures of, that I have a lot of data on, is very near where the sun is right now. The sun, there's no way we could be observing, no matter where we were in the world, to see that cluster right now, because the sun's sitting almost right on top of it. But by over here, where the moon is, on the evening of the 21st, the morning of the 21st, where the moon is, we're looking at Scorpius. So Scorpius is a real marker of the summer sky, and here we are on the winter solstice for those of us in the northern hemisphere. Would be a summer solstice for those in the southern hemisphere. We'll just call it the December solstice. So here we are on the December solstice on the 21st, and we are seeing the moon right next to the globular clusters M80 and M4, these beautiful big globular clusters in Scorpius. So we get a sense of how much of the sky we can see and how time kind of rolls around that way to think about where we're seeing the moon. Now, there's way too washed out a sky to see those globular clusters, or to even really see Antares, the big bright star in Scorpius down there. But you maybe can see the moon there, and it gives you a sense. You wait a month, and we'll be around over here, and in a month, that's probably too far. In a month, if we're around over here, and Scorpius was this direction, we're starting to see Scorpius pretty well before sunrise. So that gives us something to think about as we head toward January, to think about the fact that we can see these summer stars up there. So this is great. We see the moon. As we said, this is the December solstice. And so this is deep winter for those of us here at mid-northern latitudes. Sort of photo period midwinter is how I would describe that. And we'll return to that, but before we do that, let's realize that, okay, if we're seeing the moon over here right now, just about the same distance on the other side of the moon, actually slightly less distance, closer to the sun over here, is Mercury. And this is actually Mercury's at greatest elongation. That angular separation from the sun is right now on the 21st as great as it's going to get for Mercury. So this is an apparition of Mercury to go out in the evening sky and try to see. But it's really hard to see. If it's about as close to the sun as the moon was, and the moon was hard to see, and the moon has the disadvantage of being only 6% full, so it's a little slimmer, but the moon is still pretty bright. You know you're going to have to work to dig Mercury out of there. But you can try it. So this is your task for the week ahead if you want a challenge. Go out in the morning of the 21st, and just before sunrise, use your binoculars and enjoy the crescent moon and picture where we're seeing the crescent moon over here beside the sun. Then go out in the evening of the 21st and see if you can pull Mercury out of the glow over on this side. Now, half the distance between Mercury and the sun is Venus. So Venus is there. Venus might actually be slightly easier in the sense that it's brighter, but it's so much closer to the sun, it's going to be a real challenge. So you go out now within, right at sunset and try for the next half an hour after sunset to see if you can pull these planets out, particularly Mercury, over this direction. Now you move on over this way, and you've got Saturn, and Saturn is still looks pretty low in the southwest sky, but Saturn will be the brightest object perhaps you see down in the southwest sky as you get sunset. And we have for years been talking about Saturn doing prograde motion and then a retrograde loop and then coming back to prograde motion and dancing around the tail of Capricorn, and it's still right there, Nashira and Deneb al-Gadi, tail of the goat in Arabic. And we got Saturn and Nashira and Deneb al-Gadi making this triangle right here that you can see on off this direction. So this is great. Let's talk about, so enjoy Saturn, find Saturn, reacquaint yourself with the stars of Capricorn that it's been near. Try the fun challenge of seeing the 6% crescent moon in the morning sky on the 21st and then in the evening sky on the 21st. See if you can find Mercury in the glow of the sun. And think about the geometry of what's going on right there. But let's also think about the fact that this is midwinter photo period for those of us in northern hemisphere. And we've been getting earlier sunsets for a while now. The sunrises have been getting later and later, so we've still been losing total photo periods, total daylight. But we've been getting longer and longer, more and more light at sunset. And the reason that is we're actually pretty close to the sun. The Earth's orbit around the sun is elliptical. There's an ellipse like this. We're not nearly that elliptical. We're not that squished. We're much closer to a circle. Very hard to see by eye that it's not a circle. But we are at the closest point to the sun right now in our orbit. In a month from now, 3 weeks from now, we'll be at our very closest point. But we're at the closest point in here. We're really close. When we're closer, we're moving faster. And so when we move faster in one rotation of the Earth, so suppose we built a monument and pointed at the sun like that, one rotation later, it's not pointed at the sun anymore. I've had us move much more than we would actually move in one rotation, but just to see that, we have to over-rotate to get the sun back directly overhead. And on average, that over-rotation takes 4 minutes. So we talk about the sidereal day is 23 hours and 56 minutes. That's one rotation of the Earth is 23 hours and 56 minutes. It takes about 4 minutes to get the sun back overhead in any one. That's how much we've moved. We've moved about 1 degree in our orbit, and it takes about 1 degree of rotation, and you can calculate out just for the fun of it. Why not? Go out, calculate the time it takes to do that 4 degrees of over-rotation, and that 1 degree of over-rotation, and it turns out to be 4 minutes. And so that's what's going on. You got 1 degree here and 1 degree here that we got to over-rotate. It takes us 4 minutes to do that, except here in wintertime, we move further in our orbit than average. Not a lot further, but a little bit further in orbit. And so we have to over-rotate a little bit more than a degree, and it takes us a little longer than 4 minutes. And so it takes a little longer to get the sun back directly overhead, a little longer for sunrise to appear, and a little longer for sunset to occur. And so that's why we have for a couple of weeks now been gaining daylight on the bottom end, on the sunset end. as we orbit around this direction. So we got a lot of fun geometry to think about right now. Think about why the sun sets. So there's a project. There's another fun observing project. Go out and watch evening daylight. You should be able to now. We're not adding much daylight in the evening, but over the next 2 weeks, if you watch the daylight in the evening, you can appreciate how much we're gaining daylight in the evening. We're not gaining it in the morning yet. We're still losing it slightly in the morning, but we're gaining it more now as we get past the 21st here. For those of us in northern latitudes, we're starting to gain more daylight in the evening faster than we're losing in the morning, and you can see that. So just start to note how bright stuff is. Take a picture with your phone. Go out and take a picture with your phone at the same time every evening. Go out at 5 o'clock or 5:15 or something like that, or 4:50 or whatever works. Note how light it is. Take a picture and just watch that over the next 2 or 3 weeks, and you should be able to be really impressed about how much daylight we're gaining. And then we'll start to gain it on the morning side too, and then we're starting to gain daylight quickly. But that's what we got. Watch the sunsets. Think about our orbit. As you think about our orbit, the orientation of where the Earth is relative to the sun, appreciate the crescent moon this week, especially on the morning of the 21st. And then try to find Mercury on the evening of the 21st, if you dare. Appreciate Saturn in Capricornus. And earlier, the night before this night of the morning of the 21st, the morning of the 20th, find the stars of Libra with the moon, a nice, beautiful 10% crescent moon there. And that's what we got. I hope you have a great week, everybody. Hope you have some clear skies. And as always, thanks for watching. We'll have more for you next week.